we're going to continue talking about derivative rules. So in big relief, no more limit-based stuff. But anyway, so today we're going to focus on the product rule and the quotient rule. So when you multiply two functions together, and you look at the notation, I decided to put it in English for you to help you out. So we're going to take the first function times the derivative of the second, plus, then we're going to take the second derivative times the second function times the derivative of the first. And so I picked a really simple example. Some of you probably will want to come up with a different way to do that, and in the future that will be fine, but I just want to show you how the product rule works. So f prime of x, we're going to take the first function, 5x squared, multiply it by the derivative of the second, which is 18x to the fifth, and then we're going to add the second function, 3x to the sixth, times the derivative of the first one, 10x. So that's the product rule. Now it's just algebra and simplify. So here we're going to get 90x to the seventh plus 30x to the seventh, and you add those together, and the derivative is 120x to the seventh. Now, is there a faster way to do it? Yes, and the end game is find the derivative. So could you have multiplied 5x squared times 3x to the sixth and taken the derivative of a single term? Absolutely. Okay, next one is the quotient rule, and this one talks about with a rational function how you're going to take the derivative, and I've simplified this as well. So you're going to take the low function times the derivative of the high function, and then minus high d low over low squared. This one here has been used for years. In fact, that's the way I was taught. It sticks, and I think it does simplify the quotient rule nicely for you. All right, here we go. So f of x, we're taking that little prime. All right, so low, which is x plus 1, and it is a quantity, so remember to put parentheses around it, times the derivative of the top, which is a 1, minus the high function, or the top, which is x minus 2, times the derivative of the bottom, which is a 1, all over x plus 1 quantity squared. And right now the calc is over, and now it's just algebra. So f of x equals my f prime of x, so I get x plus 1 minus x plus 2 over x plus 1 squared, and then we're going to simplify the top, and our derivative would be 3 over x plus 1 quantity squared. A couple things to be mindful of. One is try not to multiply out your denominator. We're hoping we can cancel. Simplified form is fine. And just watch your signs and make sure you're using the right grouping symbols. Okay, so this one we're going to use the product rule. This one you'd have to decide, is it worth it to do the binomial times a trinomial and get a polynomial, or do you want to use the product rule? That's really up to you. I'm going to use the product rule. So looking at that, we're going to write down our first one, which is 2x minus 3. We're going to multiply it by the derivative of the second, which is negative 2x minus 4x to the third. Then we are going to add. We're going to take the first one, 4 minus x squared minus x to the fourth, and we're going to multiply it by the derivative of the first one, which is 4x. Okay, continuing the simplify process, our derivative. Now we're going to go ahead and, we've got binomial times binomial, so we'll go ahead and do FOIL here, which would be negative 4x to the third, and then minus 8x to the fifth, plus 6x, plus 12x to the third, and then plus 16x, minus 4x to the third, minus 4x to the fifth, and then we are going to simplify that, and usually descending order is preferred. So that's going to give us negative 12x to the fifth plus 4x to the third plus 22x. And there's your derivative. Now, here's an example of working smarter, not harder. Here, I would not use the product rule. The first thing I would do, I would write that s to the 1/2, and then s squared plus 8. And then I will distribute. I'm still working with my function, so g of s. I'm going to use my exponent rules, s to the 3/2 plus 8x to the 1/2, and then now we're ready for the derivative. So g prime, the derivative with respect to x. So power in front, 3/2 x, reduce the power by 1, plus 4x to the negative 1/2. Now, at this point, you can leave the x to the negative 1/2. You can also drop it into the denominator and write it with a positive. I'm going to leave that choice up to you, but I will accept your answer either way. Okay, this one, it's a division problem, so it is a quotient rule. All right, so here we go. So we're going to use the quotient rule. So f prime of x. So we start low, parentheses, x squared minus 1, times the derivative of the high, 2x plus 3, minus the high, x cubed, plus 3x plus 2, times the derivative of the low, 2x, all over the bottom, x squared minus 1 quantity squared. Okay, so there is our quotient rule. Now we're going to simplify and see where we land here. All right, so using FOIL, we get 3x to the 4th, and then oh boy, whoops, we've got a little bit of an issue there. I like how I catch it here, where this term should be. I gotta go back and fix. Okay, hold on. Sorry. Well, see, this is just like hanging out with me in class here. Let's change this one. That derivative should have been 3x squared. I missed the cube. Sorry about that. Okay, now, so foiling, negative 3x squared and 3x squared gives you a 0, so minus 3. And then we're going to distribute, but don't forget about your negative. So negative 2x to the 4th minus 6x squared plus 4x, which actually, watching those negatives, of course, would be minus 4x all over the quantity squared. And now at the top, just clean up the fraction so we can combine some like terms there. So it's looking like x to the 4th minus 6x squared minus 4x minus 3. Your shot would be to group, but that's not going to work. So x squared minus 1 quantity squared on the bottom. And then one more practice with the quotient rule, just to be sure. So g prime of s, and we're going to take low, 5s minus 3, times the derivative of the top, which is 2s, and then we're going to say minus the top, s squared plus 4, times the derivative of the bottom, which is a 5, all over the bottom, 5s minus 3 squared. Okay, there's our quotient rule. Now, g prime of s, so we're going to get 10s squared minus 6s, and then minus 5s squared minus 20 all over the bottom 5s squared minus 3, and then simplify the top, so g prime of s, and then we get 5s squared minus 6s minus 20 all over 5s squared minus, oh my, let's see, gotta go back and fix. Goodness, I am having issues today, but you know what? We're just gonna keep rolling so that I can fix them and I don't have to do 52 takes of a video. Fix. Some of you probably already corrected me, as you would if we were working together. Okay, there we go. And down here, let's fix this. Okay, get rid of that. Add that, parenthesis, and squared. There we go, a little touch up, and then our answer is complete. So really, both rules are fairly simplistic. It's the algebra that can be a bit cumbersome.